Hello class. Today we'll be talking about error propagation. Now error and uncertainty are pretty much synonymous, so we'll be using them interchangeably. But before we talk about error propagation, let's go back and review what error/uncertainty is. If you remember, we took the example of the red ribbon measurement in a few slides ago. Actually, in this case, it's going to be a few days ago. I hope you remember that. We said that we demonstrated that the error is always on the last digit. The uncertainty, sorry, is always on the last digit because that digit is estimated. And we said all these numbers, 265, 266, 267, or for that matter, any non-zero digit on the second decimal is valid. So 64, 65, 66, 67, 68, all of those are good. And that includes also 61 and 69. We could write the length of the red ribbon as 2.66 plus or minus 0.01 centimeters. This could be symbolized as A, which represents 2.66, plus or minus delta A, and delta A represents 0.01 centimeters. And notice the units. They are very important in this case, and we'll talk about that in a few seconds. Now 0.01 centimeters is called, or centimeter, is called absolute uncertainty. It has units, always. Keep that in mind. Now, what would you call 0.01 over 2.66? Yes, you're right. We would call that the relative uncertainty, and it is symbolized as delta A over A. Now, the relative uncertainty could be written many different ways. It could be written as a fraction, such as in this case, which is 0.01 over 2.66. It could also be written as a percentage. For example, if we had 5 over 100, that would be 0.05, or we could call it 5%. Likewise, if we had, let's say, 20 over 1,000, that would be 2%. Okay? So relative uncertainty could be written as a fraction, as a percentage. It could even be written as A plus delta A. Now, notice that there are no units in this case. That's the big difference between relative uncertainty and absolute uncertainty. Okay? Now, relative uncertainty is also a measurement of precision. We already mentioned that. The only difference between uncertainty and error, as far as we are concerned, again, is that uncertainty is a range and error is a number. Remember, for error, we could calculate it by using experimental value minus accepted value. So that will give us one number. So that would be the error. However, uncertainty, as we have been seeing, is written as plus or minus a number, delta A. So that would be a range. Okay, so instead of just being one number, it's going to be a range. But as far as we are concerned, again, I'm repeating myself here. We can use those two words interchangeably. So back to error propagation. There are two rules that you need to know. One of them is about multiplication and division, and the second rule is about addition and subtraction. So rule 1 is about addition and subtraction. When two numbers need to be added or subtracted from each other, then the uncertainty of each must be expressed in absolute form, and then the absolute uncertainty on the sum or the difference is going to be equal to the sum of the absolute uncertainties of the two numbers. Let me repeat that. If you have to determine the absolute uncertainty of a sum or a subtraction, first you have to express the uncertainties of each numbers in their absolute form, and then you add them up. Okay, now you add them up whether you are subtracting or adding. Okay, you add them up, you add the uncertainties up. And this is important to know. It's just a very simple algebra. Delta A equals delta A over A times A. So the A's cancel out, so you're left with delta A. This is important because it will help us determine the absolute uncertainties when we have the relative uncertainties just by multiplying by A, which is again the number. Rule number 2 is about multiplication or division. So in this case, if we need to determine the relative, if we need to determine the uncertainty, first we have to express the uncertainties on the numbers in their relative form, and then we add the two relative uncertainties. All right, let's take examples to clarify all this. Example 1. Let's say we have 4 centimeters plus or minus 0.1. We need to add this to 12 centimeters plus or minus 0.2. So this is an addition. Remember, and this is an addition, and the uncertainties here, what are they? Are they relative or are they absolute? They are relative, right? Because there are no units on them. So now what we need to do is convert them to absolute uncertainties, because for addition and subtraction, remember, we have to express the numbers in their absolute uncertainties and then add them up. So how do we get an absolute uncertainty from a relative uncertainty? Remember, we have to multiply that by the number, by A. So we do that. 0.10, which is the relative uncertainty on the 4 centimeters. We multiply that by 4 centimeters and we get 0.4 centimeters. And then we do the same for the uncertainty on the 12 centimeters. So that will be 0.2 times the number itself, which is 12, and we get 2.4. Now we have the absolute uncertainties. So what we do is we go ahead and add them up. So 0.4 plus 2.4, that should be 2.8 centimeters. Okay. Now we add the two numbers also, obviously, because we are adding them. So 4 plus 12 is 16. So the final answer is going to be 16 plus or minus 2.8 centimeters. All right. So I'm still here. So this is it. We could also go back, if you wanted to convert it back to the relative uncertainties. We could go 2.8, which is now the absolute uncertainty, divided by 16 to get the relative uncertainty. And there you go. And notice that the units are not shown here on 0.18. All right. So we could also write it as percentage. So this is it for example 1. Let's hit example 2. Now in this case, we are multiplying two numbers again, 4.0 by 12. And we have an absolute uncertainty of 0.10 on the 4 and another absolute uncertainty on the 12, which is 0.20. First, we have to, these uncertainties, of course, are absolute because we have units on them. So we need to convert them to relative uncertainties, and then we add those relative uncertainties. So we multiply the two numbers, and then the relative uncertainties are added. So we go ahead and figure out the relative uncertainties, and then we go ahead and add them. So we multiply the two numbers. So 4 times 12 is 48, and we add the relative uncertainties, and here we go. Oops, here we go. All right, so this video is already pretty much 9 minutes long, and I don't want the videos to go beyond 10 minutes. So feel free to pause, rewind, do anything you want, and ask questions in class tomorrow. All right, thank you. Bye.